Hello and welcome to part 3 of Description, Correlation and Causality. In the previous sections we've looked at ways of describing variables, but almost entirely looking at just one variable at a time. Now where analysis really gets going and gets useful is when you're looking at relationships between variables. So that's what we're doing in this section of the video, and we'll look at two particular ways of analysing it, which is with scatter charts and correlation coefficients. So first of all, some examples of real-world situations where this is likely to be very useful, and there are so many of them, as you can see here from these examples. So have a read of those, but before you go on, what I would suggest you do is to pause and see if you can identify the variables that are being referred to in each example, because each of these 6 examples, each one has got exactly 2 variables involved. So just pause the video and make sure you can identify what are the 2 variables involved. Okay, I hope you've done that. And then how you then go on to analyse the relationship between these variables in terms of actual methods, that really depends on what kind of variables they are, what kind of data these variables hold. So again, can you remember the data types, the way we describe different types of data, different types of variable, and the categories we tend to use are nominal or ordinal or scale. So nominal variables, ordinal variables and scale variables. So just pause and see if you can work out for each of for each variable, so there's 2 in each of these, what have we got in terms of scale and ordinal? Okay, onwards to the next one. So to remind you of these different types of data we have, well, for a start, there's qualitative data, which we don't deal with much in this module because it's mainly a quants module, we're 100% a quant module, but you need to be aware of that. So that's data that you can't represent it completely by numbers. Obviously you can to some degree, but you can't fully represent it by numbers, like speech, photographs, focus groups, transcripts and so on. That's qual. Then when you come to quant data, which is everything that you can fully represent with numbers, then what we call the lowest level of that is nominal data, where the order of the values doesn't matter. So put some numbers on there, but the numbers are just standing as labels. So if you have data on people's nationality, favourite food, language they speak, religion, then you put numbers on, and all the numbers are doing is labelling them. Ordinal data, this category of data, ordinal data, again you're using the numbers as labels, but the order of the numbers now matters. So if you're talking about favourite food, if you said 1 was pasta, 2 was potato, and 3 was rice, it's not saying that rice is like more than pasta. So the order doesn't matter, but here the order of values does matter. However, the ordinal one is the one that confuses most people because the gaps between the values don't really have a meaning. So generation, for example, isn't necessarily it's not necessarily the same number of years between somebody in one generation and the next, and between that generation and the one that comes after that. First class, business class, economy. If I said that, if I was going to label this, and I decided to label it so that, let's say, get a pen. If I decided to say that's first class, I'm going to call 3. Business class is going to be 2, and economy, air tickets is 1. That doesn't mean that business is twice as good as economy, or first is 3 times as good as economy. It doesn't even mean that the difference from here to here is the same as the difference from here to here. It just means that this is better than this and this is better than this. Yeah. So that the size and the gaps between the values has no meaning. So that's something to be careful of. And then finally, when we get to the top one, scale data, this is when it's easier again because the gaps between the values are meaningful. Price, temperature, population. So you can treat things really more like you treat numbers normally. So ordinal is the one that's going to cause you problems if anything does. Hopefully you can remember that from, oops, didn't mean to go on there. Hopefully you can remember that from previous years. Again, before we go on, really, if you want to get the most out of this, you should pause here, go back to that previous slide, which had the examples, and go through each of those variables, 2 in each example. What type of data is each one? And then we're going to get to the answers in the next slides here. So, what we're going to do then is look at types of variable here. So when we have two nominal variables, so for example, relationship between is a country a trading partner, so that's a nominal thing, that's a yes or a no category. And does it get aid from the other country, yes or no? So you've got two categories, two categorical or nominal variables. If you're looking for some kind of relationship between those, there's particular tests, particular ways you can set that out. We look at that in lecture 5. Tests for that. Sometimes you've got one nominal, so category, and a scale variable. So here, in this one here, hopefully you've seen that there's the cost of the fertilizer is a scale variable, but then the way it's supplied to private or non-private, so private or public, that's a category. So the nominal variable is this one, price of it is this one. Here, obviously the category male or female, that's the nominal. How many hours they work is the scale variable. So you're looking at, is there a relationship between the size of this scale variable and the category you're in here? That's a really important area, and we'll return to this in the next lecture. And there'll be more tests on that in the lectures that follow as well. And finally, in these 3 examples, both of the variables are scale variables. So school enrollment, poverty, size of farms, efficiency, amount of aid you get, the amount of pro-poor spending the government indulges in or provides. And these concern a relationship between these scale variables and these scale variables. In other words, numeric variables. And that's best described by correlation. Please note that in the word correlation sometimes is used to describe all these things. So you can have correlation between gender or religion and activity, crop choice, categorical variables as well. But in terms of, it's more used for numbers, especially when you get to correlation coefficients. We talk about correlation. So it's most often used for 2 scale variables. And of course, before you dive into correlation coefficients, what you want to do is get a feel for the data by using a chart. And the best chart for this is a scatter chart. So let's have a few of those. So here's the first example. All countries, 2008 from World Development Indicators. Primary enrollment here. The age dependency ratio. So that's the ratio of people of working age to overall population. And see, as the other way around, the overall population to people of working age. So that the more you go up here, the more people there are, mouths to feed, people to look after for every single person working. So the more that goes up, the more primary enrollment goes up. And you can see here there's a pretty strong pattern this way. You can see it's a clear kind of upwards drift. So I describe that as a strong positive correlation. It's positive because it's going upwards, strong because it's pretty clear. And you can ask yourself though, why we see that, but that's the next section on causality. This one here, again, you can see when we're looking at primary enrolments versus the population, the proportion of the population that are not literate, that again, you can see a pretty clear downwards line, but it's pretty obvious there's a shape there. So it's quite strong again, because you can see the shape quite clearly with downwards trend, but because it's downwards, it's negative. So again, it's strong, but it's strong negative correlation. Here's our third example, looking at percentage of population illiterate over 15, number of people per doctor. Again, positive, it's going upwards, fairly strong because you can see clearly there is an upwards trend, but not as strong as the others. So maybe a moderately strong or fairly strong positive correlation. So you should be able to see then how you use these 2 dimensions. There's how strong it is or weak it is. So how clearly you can see an upwards or downwards trend. So that's strength of correlation. And then there's positive or negative, depending on whether it's going upwards or downwards. We need some more precision, so we need a way to put a number on this. This is what Stata will do for us, or Excel by typing in this formula. If you just say correlation coefficient, it means Pearson's correlation coefficient. There are other correlation coefficients as well. For your practical work you're going to do for this module, for dissertations, for future work when you're in your careers, just use Stata or whatever program you're using, or Excel. But it is useful to understand how we do it step by step. So the next few slides just show you how you calculate that if you wanted to do it step by step. So here's an example. We've got fertiliser use here, and maize yield data here. So as you imagine, as you put on more fertiliser, you get more maize. So it's a fairly strong positive correlation. There's the figures there. And then this is how you would work out from this data a correlation coefficient between these two things, the steps you would do. First of all, I just got rid of the scatter graph a second. First of all, what you need to do is for each of these two variables separately, you work out the mean and the standard deviation. So here's the calculations here, the mean, that's just the average fertiliser use, average maize use, and then the standard deviation, which shows you how spread out they are. So how much variation is there in these numbers as measured by the standard deviation. Put that in there. Step one. Step two, what you do then is go through one of the variables, the first one, and subtract the mean from each one. So that's called, it's part of the process of normalising it. So instead of looking at a value of fertiliser of 39, you're saying, okay, this 39 means it's 39.5 above the average, because that's the average down here. So you're subtracting the average from each value. So the negative ones here, they're where the fertiliser use is below the average of 25. So converting everything into above or below its own mean. Do the same thing for maize. So again, the positive ones here where it's above the average of 543. Negative ones is where it's below the average of 543. So calculate that for the whole column. Then what you do is these differences from the mean, you multiply them together. So you multiply all the differences from the mean together. And then when you've done that, you find the average of that. So you've got quite a mouthful. What you've got is the mean product of the distances from each mean. Quite a mouthful. Mean product of distances from each mean. And this is also already a pretty good measure of correlation. If they're positively correlated, this will always be positive. Negative correlated, it'll always be negative. But unfortunately, you get these really stupid big numbers. So the final step gets rid of the big number. The final step is this. You divide this number by both the standard deviations you had originally. So divide by this and divide by this, which is what this is doing here. And that gives you the correlation coefficient. And that has this really nice thing that not only is it positive and negative, but it always works out between plus one and -1. But just to emphasize, we're not going to test you on that. I would never bother doing that. If I just wanted the correlation coefficient, I'd just bang it into Stata or Excel. So just use the formula. That is just to show you how you work it out. So step by step, it always comes out between -1 and +1. -1 is perfectly negative. 0 means there's nothing there at all. +1 is positive correlation. But you very rarely get those exact, or never get the exact extremes. You get close to them. So if we apply that, we can now put a number on it. So that the strong positive correlation came out as 0.79 positive. The strong negative correlation came out as negative 0.71. So strength is almost the same exactly, 0.7 something. But this one's negative, hence the minus. And this one was positive again, but 0.54 because it's not as strong, fairly strong and positive. And then, again, the next step is to think about why. I mean, why am I seeing this? Is this illiteracy causing the number of people per doctor or something? What's going on? And that's what we're going to look at in the next section. What makes us see these different patterns? So, as I say, next step is to, once we've described the correlation patterns, is to go on to causality. How do we know that? How do we explain the things that we're picking out when we've analysed the correlation relationships? And go on to causality. But that's going to be in the next video. So for now, thank you for watching.